section number 29, we are going to continue with fractions. We are going to talk about powers and roots of fractions. Powers and roots of fractions. If you were asked to compute 2/3 squared, well, what's in the brackets is the base, and I'm going to multiply it by itself 2 times. Multiply the base by itself 2 times. Of course, I'm going to get 2 times 2 is 4, and 3 times 3 is 9. But I'm also going to get, like I said, 2 times 2. 2 squared over 3 times 3, 3 squared. If everything is in the brackets, you get to square the 2, and you get to square the 3. 2 squared is 4, 3 squared is 9. We got the same answer as before. That is, if somebody asked me what 5/4 squared is, whether I write this down or not, I would think, how much is 5 squared? And how much is 4 squared? 5 squared, 4 squared. Here's the answer. You don't need to write this. Don't write it. 5 squared is 25. 4 squared is 16. That's just what I wrote. 3/2 cubed. Why, that's 3 cubed over 2 cubed. Over 2 cubed. 3 cubed. 3 times 3 is 9. Times 3 is 27. And I divide this by 2 cubed, which is 8. And there's the answer. If this number in the brackets is not 0, and it's not, it's more than 0, if I raise it to the 0 power, I get 1. 7 2/3 is not the number 0. So when I raise it to the 0 power, I get 1. 0 to the 0 is not 1. It is indeterminate. We don't know what it is. Somebody asked me what 8/9 squared is. I think 8 squared over 9 squared. Somebody asked me what 10/5 squared is. I would say that's 2 squared, because what's in the brackets is 2. 10 divided by 5 is 2, and 2 squared is 4. You could, if you like, say 10 squared is that number, 5 squared is that number, and 100 divided by 25 is 4. You're dealing with hundreds and 25s. I'm dealing with 2. I definitely know what 2 times 2 is a lot faster than I know what 100 divided by 25 is. You learn 2 times 2 in the 2nd grade, as opposed to 100 times divided by 25, which may have been the 4th grade. Why? Because 2 times 2 is easier. That was powers of fractions. Now let's talk about roots of fractions. Or just roots. If somebody asks you what this is, well, you need to realize, whether you write it down or not, that it's shorthand for that. What positive number times itself 2 times gives you that number? Well, if you don't know, a lot of students say, I don't know, I can't do this. Well, you're not trying. You do 1 times 1, that's 1. That's less than 25. 2 times 2 is 4. That's less than 25. Multiply numbers by themselves 2 times. And eventually, you should get, in this case, 25. The answer is 5. Somebody asked you, what is the 4th root of 81. What times itself? What positive number? If it's an even root, if these numbers are even, you want a positive number. What positive number times itself 4 times will give you 81? Well, I don't know. Fine, don't know, but don't just give up. Multiply 1s by themselves 4 times. Multiply 2 by itself 4 times. 4 times 4, that's 16. That's below 81. Multiply 3 by themselves 4 times. Now 3 times 3 is 9. You should know that. We know up to the 12 times table. 3 times 3 is 9. 9 times 3 is 27. 9 and 3 are not above 12. So we should know 9 times 3, 27. And now 27 times 3, 27 is more than 12. We shouldn't know the 27 table. So you should say, you know what, let me look at it differently. 3 times 3 is 9. 3 times 3 is 9. 9 times 9, 81. What I just did is I invoked the associative law. You can bracket however you like. This is 9 times, and that's 9. It's 81. Oh, 81, that's what I wanted. This is equal to 3. 3 times itself 4 times gives me that number. So it is negative 3, but then again, you don't know about multiplying negative numbers yet. So that is why I said, the answer is not negative 3 as well. If it's an even root, you want a positive number. Okay. So, somebody asked you, what is the 5th root of 32? What times itself? This number of times gives you 32. Well, it's not 1. Get over the 1. 1 times 1, any number of times is 1. 4 times 4 is 16. Times 2 is 32. It's that number. The answer is 2. Okay, but this section was entitled Roots and Powers of Fractions. With respect to the roots, we haven't looked at fractions yet. But fractions are no big deal. Here is the rule. Regardless of the number in front, let's call it n. If you have a fraction underneath the radical symbol, you can take the nth root of a, and you can take the nth root of b and divide them. That is, if somebody asks you, what is the square root of 25 over 9? Remember, there's an understood 2 there, whether you write it or not. The rule says you can take the root, the second root of the top, and the second root of the bottom. You don't want to write the 2, don't write it. Square root of 25 is that number. The square root of 3 is that number. And you don't even have to do this. Ask yourself, the square root of 25 is 5. The square root of 9 is 3. The answer is 5 over 3. Very important rule. So, somebody were to ask you, what is the square root of 9 over 16 plus 3/2 squared? Well, this number, the square root of 9 over the square root of 16. 3 over 4 plus 3 squared over 2 squared. Denominators are the same. In addition, you want them to be the same, and they are. Add the numerators. 3 plus 9 is 12. 12 divided by 3, 12 divided by 4 is 3. So, now we know what this equals. Equals 3. So, there's some wise Alex said, okay, so let's see if you understand this. How much is this going to be? How much is this going to be? Now, you can work it all out again. But do you know that's 3? That's 3. Plus 4, why, that's 7. And there's no point in working this out again. You can say the square root of 9 is 3, the square root of 16 is 4, plus 3 squared over 2 squared plus 4. That's 12 over 4 plus 4. That's 3. 3 plus 4. But most of the work, that work that's in the blue, that's exactly what we just did a moment ago. Don't reinvent the wheel. Whenever you see this, for as long as you can remember, it's 3. Now, I'm not expecting you to remember in 5 minutes from now that that's 3. But we just did it. It's 3. You see it again, you say, oh, I recognize that. That's 3. 3 plus 4 is 7. So, if somebody now said, okay, tough guy, how much is this? How much is it? How much is the square root of 9 over 16 plus 3 halves squared? Well, that's 3 divided by 3. You should say, oh, that's 1. 3 divided by 3 is 1. Oh, I don't know why the square root didn't come out. Sorry. That numerator is 3. What's above this line is 3. When you see this, 3. Again, I don't expect you to remember it. I mean, I assure you, I won't remember that that's 3 in a short time. But we just did it. Now I know it's 3. 3 divided by 3 is 1. It's just a pain in the neck way of writing the number 3. But it's 3. How do we know? Because one time and one time only, we worked it out and we got 3. Somebody asked you, what's the square root of 9 over 144 plus 1½ squared? Well, you should say the square root of 9 is 3. The square root of 144 is 12. 12 times 12 is 144. Plus, before I square, I have to have a fraction, not a mixed number. 2 times 1 is 2, plus 1 is 3. 3 over 4. 3 over 2, excuse me. 3 over 2. Then I'll say 3 goes into both of these numbers 1 time and 2 times. This is a quarter plus 3 over 2 squared. 3 squared over 2 squared. In addition, the denominators are the same. Keep it, add the tops. 1 plus 9 is 10. They're both even, so I know 2 goes into both of them. Possibly larger numbers go in, but not in this case. Well, the answer is 5 over 2. What does that top line equal? Well, 5 over 2, or 2½ 2 goes into 5 2 times with 1 left over. Divide the remainder 1 by 2, by what you're dividing by. Sometimes you want to do the division first. I think earlier I gave you, see if I remember. Oh yeah, I asked you what 10 over 5 squared was. Sometimes it's better to simplify before you square. 2 squared is 4. In this case, before you take the square root, sometimes it's better to simplify. 75 divided by 3. Yes, 75 cents. You have 3 what? Answer is you have 3 quarters. 75 divided by 3 is 25. And I know the square root of 25 is 5. For the record, if I thought of it like this, I'm in trouble. Because I don't know the square root of 75 and I don't know the square root of 3. But when I divide them, I do. In fact, if somebody asks you this problem, The rule says that you could put it together. If the rule says the square root of a over b is equal to the square root of a over the square root of b, it doesn't mean that you can just go that way. When you have the square root of a fraction, you can take the square root separately. You can also go that way. That's what equal means. If the left-hand side equals the right-hand side, then the right-hand side equals the left-hand side. And if somebody gave me this problem, I would think of this. Why? Because you have to see the future. You have to know your division. You have to know, oh, 70, not only do I know 75 divided by 3 is 25, but I know the square root is 25. Sometimes you want to make it one square root and do the division or multiplication first. Since I made that comment, let me just write down this other rule, which we probably will not be using right now. If you have the square root of a product, you can take the square root of each of them. Only if both numbers are not negative. One number can be negative, both numbers can, well, zero numbers can be negative, but they both can't be negative. That is, if somebody asks you, well, what is the square root of 20 times the square root of 5? Well, you don't know the square root of 20, you don't know the square root of 5, but you know what? It equals the square root of 20 times 5, but 20 times 5 is 100. And here's, you know why. You know why? You know the square root of 100. Okay. Now, if somebody asks you, what's the square root of 16 times 9? Instead of multiplying, you can say, well, this is the square root of 16, which I know, times the square root of 9, which I know is 4 times 3, which is 12. Sometimes you put a dot for multiplication, but not usually in arithmetic class. Okay. So, somebody asks you, what's the square root of 81 over 9? You can do the division first and get 9 and say the answer is 3. Now, I want to talk about something. If you think, for example, right or wrong, if you think 3 plus 6 is 11, don't write 28. If you think this is 11, don't write 28. If you think this is 9, don't write 13. If you think the answer is 9, write 9 down. If you think the answer is 28, right or wrong, write 28 down. If you think that 7 plus 4 is 13, but you write down a different number, what is the odds that you're going to be right? You have a much, much better chance of writing down the number that you think it is. If you think 7 plus 4 is 13, put down 13. If you put down another number, it's almost certain to be wrong. Turns out you were wrong here as well. Now, what am I getting at? Well, let me clean off some space and I'll tell you. I see this all the time, and it amazes me. The student will verbally say this: the square root of 25 is 5. But then they don't write down 5. They write down another number. If you think the square root of 25 is 5, please write down square root of 25 equals 5. It doesn't equal the square root of 5. If you think the square root of 16 is 4, don't write down the square root of 4. And if you did, why don't you say the square root of 4 is 2? Probably in your language you would write the square root of 2, which is also wrong. If you think the square root of 4 is 18, please write down 18. You're wrong. But what are the chances that you'll be right if you put a square root sign on top of it? If you think the square root of 100 is 10, put 10. Do not say, oh, this is simple. The square root of 100 is 10, and then you write that down. 100 times out of 100 times, if I asked you in this box over here to write down 10, 100% of you, 100% of the times, would write down that number. Not one of you would write down the square root of 10. If you think the square root of 100 is equal to 10, please put down 10. It's suicidal to put down a number other than what you think it is. If you think, whatever you think 7 plus 2 is, if you put down a different number, it's going to be wrong. The odds that you think 7 plus 2 is not 9, a number other than 9, but then you say, I don't like my number, I'm going to put down 9. It ain't going to happen. It isn't going to happen. If you think the square root of 100 is 10, put down 10. It amazes me how students will come to my office and I'll write down, say, the square root of 25, and I'll say, write down what this equals. And they would say, oh, I didn't know that. That equals 5. And then they write that down. Hint, that's not 5. Well, you can't read it. I wrote on it. That's not 5. This is not 5. I asked you to write down 5. I doubt you would write that down. You know why you wouldn't write this down? That's not 5. This number is not 5. It is square root of 5. Don't commit suicide with these problems. If you think the answer is 20, don't write down square root of 20. Then you don't even realize, you know what, I'm putting down a different number. If you think the answer is 20, put down 20. Do not put down the square root of 20. And on that note, that finishes the section on powers and roots of fractions.